Okay, hey, so we are in the business of solving triangles these days, and not we're not confined specifically to right triangles where we can do lots of stuff. We can do the Pythagorean theorem, we can do SOHCAHTOA and any of those right triangle ratios, but we're learning how to do this with what we call oblique or non-right triangles. And the law of sines is super helpful to us. It took us a long way in certain scenarios. There's a couple of scenarios where the law of sines is not going to be as helpful as we would like. All right. One of the bits of information about a triangle that we know we have only one exact unique triangle is when we have a side of the triangle and then the angle right next to it, and then the other side from that angle. So in the triangle I have drawn up here, I have side, then angle, then side. And this is going to be exactly one option, one triangle. But the law of sines is going to fail me a little bit because here's what we did. Remember, law of sines, A over sine A equals B over sine B equals C over sine C. And I told you guys, look for the pairing where you have both bits of information, the angle and its opposite side. And when we get this stuff given to us, we don't have any of those pairings. I have this side, but not its opposite angle. I have this angle, but not its opposite side. I have this side, but not its opposite angle. And so any type of equation I try to set up is going to give me two unknowns. And when I have one equation and two unknowns in algebra, I'm in trouble. And so want to introduce you to another law that involves some trigonometric ratios. It's called the law of cosines, and you've seen part of it before, actually. You just don't realize it. You guys may recall with right triangles, we have something called the Pythagorean theorem. Pythagorean theorem, c squared equals a squared plus b squared. And a lot of you like to say a squared plus b squared equals c squared, and it looks weird for me to want to write it this way, put the c value first, but the reason that I tend to do that is because of this thing that's known as the law of cosines. And the great thing about the law of cosines is where the Pythagorean theorem only for right triangles. We can only use it. And so if we're not dealing with a right triangle, that's out of there. But the law of cosines will work for any triangle. And what it states is that this equation here is just a partial picture. It says there's this, but then there's more to it. C squared equals a squared plus b squared minus 2ab cosine angle C. All of that, c squared equals a squared plus b squared minus 2ab cosine C. That's the law of cosines. You probably don't like that. It looks like it's a mess, and I get that, but it's actually super helpful and super valuable. It's worth it to learn the law of cosines and be real familiar with it. The nice thing for you, at least right now, is you don't really have to memorize it. You're going to be able to reference it a lot. I think the more that you use it, the more you might crud.